Welcome back. In this video, we are going to look at how we can tackle this particular integrand on the board, right? So we have a polynomial function and an exponential function. So today, I'm just trying to use the traditional method and then use the tabular method as well. I'll combine both, then you enjoy both method of integration by parts in here. Okay, so let's dive into it. So we begin with the traditional method. Okay, so here let's x squared is equal to u. Okay, so we're going to have u du is equal to 2x dx. Okay, so once we have this, then we can say that our div is equal to 5 over x dx. So we integrate both sides and we have our v to be equal to integrate 5 power x dx. We're going to have 5 power x over ln 5. Okay, so once we have this argument and we have this argument, we quote our formula for the integration by parts. So integration is equal to u v minus integral v du. Now we have all these arguments, so we substitute them where x squared is u and our v is 5 power x over ln 5 minus integral v, which is 5 power x over ln 5 times du here is 2x dx. Okay, so we simplify this. I'm going to have s squared 5 power x over ln 5 minus, we factor the constant out, which is 1 on ln 5, 1 on ln 5, integral 2x 5 power x dx. Okay, so once we have this information, we can go ahead and integrate the second time because of the x variable we are having in there again. So okay, let's try and bring the 2 out. So we're gonna have 2 over ln 5 so that we have x 5 power dx. Okay, so we integrate the second time. So by part again, right? So we choose our u equals x, where we have du is equal to dx. So we're going to have dv is equal to 5 over x dx. Integrate both sides and we have 5 over x over ln 5. Okay, so we quote the formula again, but we substitute in place of this argument. So we're going to have I equals s squared 5 over x over ln 5 minus 2 over ln 5, then uv minus integral v du, right? So we're going to have I equals s squared 5 over x over ln 5 minus 2 over ln 5. Then here our u is x and our v is here. So we have x 5 power x over ln 5 minus integral v, which is 5 power x over ln 5. The u here is the x. Okay, so we continue from here. We have s squared 5 power x over ln 5 minus 2 over ln 5 into x 5 power x over ln 5 minus, when you integrate, okay, let's try and bring the 1 on ln 5 out first, right? So when you bring that out, we're going to have integral 5 power x dx. Okay, so we're going to have I equals s squared 5 power x over ln 5 minus 2 over ln 5 into x 5 power x over ln 5 minus 1 on ln 5 into integral 5 power x dx is 5 power x over length 5 plus our constant of integration. Okay, so now let's come here. Okay, so we come here and simplify the expression. We're going to have s power 5 over ln 5 minus 2 over ln 5 into x 5 power x over ln 5 minus 1 on 5 times 5 power x over ln 5 is going to be 5 power x over ln 5 all squared. Okay, plus our constant of integration. So let's try to expand this bracket here. So we're going to have I equals s squared 5 power x over ln 5 minus this. When we expand it, we are going to have 2x 5 power x over ln 5 all squared minus this is minus and then it's minus, so it's going to be positive. Okay, so we're going to have 2 into 5 power x all over ln 5 power 3. We have power 2 here, we have power 1 here, it's going to be power 3, then your constant of integration. Okay, so this becomes the final answer to this particular problem. Now, this is the traditional way of solving by parts. Let's use the tabular method and see how swift, how fast this is going to be. Okay, so we use the tabular method, which is the DI method, the differentiation integration. Okay, so the DI method, okay, the DI method. So the DI simply means D is differentiation, I is integration. So look at this function. Which one are you choosing as your differentiation and which one are you choosing as your integration? So basically, you're going to choose the polynomial function as your differential function and then the exponential function as your integral. Okay, so we have this here, s squared 5 power x dx. Okay, we choose s squared as the differential function, so we have s squared here, then we have 5 power x here. Okay, so here when you differentiate s squared, you're going to have 2x. Okay, we differentiate the polynomial function until we have a constant. Okay, so we come again, when you differentiate 2x, you're going to have 2. Okay, differentiate again, you're going to have 0. Okay, it doesn't really matter, you can leave it here or come to the 0, that's okay. So come here, when you integrate 5 power x, you're going to have 5 power x over ln 5. Okay, integrate again, it's going to repeat itself, but it's going to be what? Squared. Okay, then integrate again. Okay, it's going to repeat itself, so it's going to be 5 power x over ln 5 or cube. Okay, so you reach your limits where the 0 are. Okay, so this is the crucial aspect. You effect the signs on them. So you move in diagonal way. You know, the tabular method, the formula is uv minus integral v du. So meaning that the first term is positive, the second term is negative, meaning if you have the third term, it's going to be positive. So that is why we have plus here. Okay, so let's try to do the same knowledge here. So we have this, we are applying it diagonally. So this to this, positive, this to this, negative, this to this, positive. So interesting, right? So here we're going to have s squared multiplied by this. We're going to have s squared 5 power x all over length 5. Okay, then 2x times negative is negative 2x. Negative 2x times 5 power x over length 5 squared is going to be negative 2x 5 power x all over length 5 all squared, right? Then 2 times positive is going to be positive 2. Then positive 2 times this is going to be plus 2 into 5 power x all over length 5 cube. Then don't forget your constant of integration, so plus c. All right, so from here you can see clearly that you have your solution. Very simple than going through the traditional way of solving it. This sometimes it doesn't work for some functions. That is why we have to know the traditional way, whether hook or crook. So both are easy, but this is for objective wise. So you can see that we have s squared 5 power x over length 5. We have it here. We have negative 2x power 5 power x over length 5 squared. We have it here. We have 2 5 power x over length 5 cube. We have it here plus our constant of integration. So we have basically everything. So that is the interesting aspect for the I method. So employ this method in objective wise. When you are dealing with objectives, one you need quick answer to prove yourself. Okay, so just apply the DI method and go away. This is for theory wise. Okay, so that it fetch you some a little bit of marks. Okay, so thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mate, and I'll give you more updates. Bye bye.